So in this video, we will discuss about the average power across an inductor. Let us say we have an inductor of inductance L, and that inductor is connected across an AC which supplies a voltage of V equal to V0 sine omega t. Clearly, a current flows through the inductor, let's say I. The direction of the current always changes since it is an AC. If in the first half cycle it is in the clockwise direction, then in the next half cycle it will be in the counterclockwise direction. Now we have the current I in the circuit. We already discussed that current always lags behind the voltage in an inductive circuit. So I can write I equal to sine omega t minus pi by 2, and clearly that lag is pi by 2. That is, the current always lags behind the voltage by a phase of pi by 2. We discussed this. Now the power at any instant, let's take P for representing power. We have power is equal to voltage into current. Also we know power is equal to, by definition, power is the rate of work done, dW divided by dt, where W stands for the work and T for the time. So I can replace the power using dW by dt. Now let's substitute V0 sine omega t for V. So this is equal to V0 sine omega t into I is actually I0 sine omega t minus pi by 2. Clear? Now we have I is actually I0 sine omega t minus pi by 2. Now this can be written as I0 into sine. If I take the minus, it will be pi by 2 minus omega t. Clear? I take the minus from both these terms so that this term will get reversed. Now you know sine of minus theta is actually minus sine theta, so that I can take this minus out of the sine. So that will be I0 times minus sine pi by 2 minus omega t. Again, sine 90 minus theta, that is sine 90 minus theta is actually cos theta. So this is equal to, I can put this minus on the left, so it will be I0. Now the sine 90 minus theta is cos theta, cos omega t. So I can write this term as minus I0 cos omega t. Therefore dW divided by dt will be V0 sine omega t times minus I0 cos omega t. Clear? Rearranging, you will get dW is equal to minus V0 I0 sine omega t cos omega t. Let me take this dt to the right into dt. Now this can be simplified as dW equal to minus V0 I0. Let me divide and multiply with a 2. This 2 and 2 will get cancelled. It will be the same equation as before. 2 sine omega t into cos omega t dt. Clear? If you cancel these two, this is the same equation as before. So you know 2 times sine theta cos theta, that is, let me erase this. We have actually sine 2 theta is 2 sine theta cos theta. Okay, so dw is equal to minus v0 I0 by 2. 2 sine omega t cos omega t is sine 2 omega t dt. This is the work done at any instant. So to get the total work, let's represent total work as W. You need to integrate it from 0 to, see the variable in here is time. So 0 to the full time period t, minus V0 I0 by 2 sine 2 omega t dt. Now you can take all the constants outside. So this will be W is equal to, the total work W is equal to minus V0 I0 divided by 2 integral 0 to t sine 2 omega t dt. So this is equal to minus V0 I0 by 2. See, integral of sine is minus cos. Minus 2 cos omega 2 minus cos 2 omega t by, you have to divide it with 2 omega. Let's put 0 to t. The limit 0 and t. That is, we have integral sine ax dx is actually minus cos ax by a. Yeah, you don't forget the constant. This is the chain rule. Okay. Now again, you can take the constant value out of the integral sign. That is, this 2 omega is constant. So the total work W is equal to minus V0 I0 divided by 2 and 2 will make 4 omega. 4 omega. This minus, you can take that to outside and this will become plus. Now cos, see, I have to replace this omega. We have omega is equal to 2 pi divided by t, where t is the time period. So cos 2 into 2 pi by t into t. Now put the limit 0 to t. So W is equal to V0 I0 by 4 omega cos 4 pi by t into t. Now let's put the upper and lower limit. So this will be V0 I0 by 4 omega. First substitute the upper limit, that is cos 4 pi by t into, instead of t, let's put this one t, minus, if you put the value 0 for t, this whole term becomes 0. So that will be cos of 0. Now you can cancel this t and t. We know the value of cos 4 pi is 1. So this is equal to V0 I0 by 4 omega into 1 minus cos 1, cos 0 is also 1. So the value becomes 0. Clear? So the total work done during one complete cycle is actually 0. Now we have the average power. P average is equal to total work divided by total time. Total time is the time period. So that will be 0 by t, which is equal to 0. So average power in a purely inductive circuit is actually 0. Clear? And clearly there is V voltage V0 sin omega t, and there is also a current I equal to I0 sin omega t minus pi by 2. Even though there is flow of current through the inductive circuit, this current provides no power. So that current is called actually wattless current. We discussed this in the LCR circuit. The current which provides no power to the circuit is called the wattless current. Clear?